Hello everyone, welcome to my online instructional video. This is PIDP 3240, Assignment 5 by Zach MacArthur. Hello everyone. Alright, today you are lucky. I'm going to give you just a little taste of what I teach my electrical apprentice students on a daily basis. Alright, we have this question. What size EMT is required for 6 number 12 T90, 2 number 8 RW90, and 3 number 4 RW90 stranded conductors? Alright, there's a lot of information here you may or may not understand. So let's start at the beginning and get you caught up so at least you can follow along. EMT is electrical metallic tubing. It is a type of raceway that we use to transport our conductors from the panel to the point of utilization, whether it be a receptacle, light switch, or other type of electrical component. Then we have 3 different sizes of AWG or American wire gauge size conductors. We've got number 12, number 8, and number 4. All you need to know about this is the numbering system's kind of backwards. As the AWG number gets larger, the physical size of the conductor is actually smaller. Alright, if we had all the insulation and all the conductors the exact same size, same insulation, we can just go to the appropriate table 6A to 6K. We don't have all the same conductors and the same insulation. Our insulations are T90 and RW90. The 90 stands for 90 degrees Celsius, and the T stands for thermoplastic. So that conductor, when it exceeds that 90 degrees Celsius, it's actually going to start to melt. Where RW90, it's a little bit of a higher quality conductor. When it reaches that 90 degrees Celsius, it is a thermoset, and it is going to maybe crack a little bit, but it isn't going to completely melt. Alright, in this question, like I said, we had 3 different AWG sizes. This is a math question, and it's based off the 2018 electrical code book. But I'm going to go through the question. I'm going to label the 3 different sizes I have from smallest physical size to largest physical size, because that's the way that the tables work in the electrical code. So over here, I showed that we put EMT as table 9I. We're going to need that at the end. And all these conductors are stranded. So to find the area of each conductor, I have to go to 10A. So I have number 12s. I have number 8s, and I have number 4. I have 3 different size conductors in that conduit. Alright, I did the hard work for you, and I went and found the areas for each conductor so that you don't have to, because you probably don't have a code book handy. But the number 12s, we have 6 of them. So 6 times, and the area of each number 12 conductor is 8.47 millimeters squared for a total of 50.82. I'm pretty good at math, I know, that was quick. Next are number 8s. We have 2 of them in that conduit, and each of those conductors have an area of 28.17. For a grand total of 56.34 millimeters squared. And our largest conductor, we have 3 of them in there. And the table tells me that each of these conductors has an area of 52.46 millimeters squared. For a grand total of 157.38 millimeters squared. Alright, next step, we have to add all of these areas together to find our grand total of area taking up inside that conduit. The total is 264.54 millimeters squared. That's like step 1 of going through this problem. So I know the total area that my conductors take up, but that was just from table 10. over here I said we had to go from table 8 and table 9 as well. So table 8 is going to be 40% fill. I am only allowed by code to fill any conduit that has 3 or more conductors in it to 40% fill, because when we run electrical current through a wire, it heats up. We need air movement in there to dissipate that heat so that we don't have problems down the road. So what I'm going to do with this is I do take that to table 8, but table 8, 3 or greater conductors, we have well more than 3 conductors in here, equals 40%. I then take that to the appropriate table 9. EMT is table 9I. So I take that down to table 9I, and in the 40% column, I am going to go down until I find a number that is at least this large. If I found 264, that would not be good enough because it can't handle the 0.54. So I go down table 9I in the 40% column, and I find that I require a 35 trade size conduit, 35 millimeter. If you wanted to know what that was in inches, that's 1.25 inches. So 35 trade size conduit at 40% fill can actually handle 376 millimeters squared. I hope you enjoyed today's lesson and just a little bit of insight on what the math that I teach on a daily basis is, and I hope you enjoyed this lecture. Thank you. Goodbye.